Without further ado, I'm going to let Martin take it away. By the way, Martin, I love your background. I love that you have a drum kit in your background. My background isn't as cool as yours, but I could almost say that it is actually, you know? But I think we're on par. Take it away,
Yeah,
Martin. Great to have you.
all right. Okay. So thanks. Hello, everybody. Thanks for joining the beginner stage. You are in good company here. So my name is Martin, and I will do today a short beginner-friendly presentation on a topic which is usually very easy to understand, very easy to set up, very easy to let it do its own thing, but also very easy to forget about. And that's the existential deposits in substrate. I observed that a good presentation usually starts with agenda, so I have that on the next slide. Only a few points here. As you may have already guessed, most of the time I will be talking about myself, and if the time permits, I will also talk about the mentioned existential deposits. We will look how the existential deposit work in a substrate. We will check what is under the hood with focus on two most used palettes, balances, and tokens. And we will try to also have a look how we tackle the issue in Basilisk, where we have or hope to have many assets with dynamic prices, and therefore dynamic involving existential deposits as well. Myself, just quickly, I'm originally from Slovakia, living in Italy. I see myself currently as a software development enthusiast, interested in many things, perhaps one thing too many, but my background is mostly C and C++ and Python. I worked on many different projects in these languages, starting from big data solutions through the web backend development, all the way to mobile development. Until recently, until 1.5 years ago, I somewhat accidentally joined a blockchain project, and my path and path of guys from Basilisk and Hydra crossed each other. So that means I am relatively new to blockchain world. I was not really seeking anything to do with blockchain at that time, but words have been told and arrangements have been made. 16, 17 months later, I'm giving a talk in Substrate development conference. Yeah, if you tell me that at that time, I wouldn't believe. So as mentioned, I joined Hydra and Basilisk as core Rust developer. So let's have a look what they are. So what we are trying to do here, and also that we can have an idea where this topic is coming from. I work on Hydra and Basilisk as a Rust developer. So both projects are projects in Polkadot ecosystem. Basilisk, already running as parachain on Kusama, is liquidity bootstrapping protocol built for Kusama, and Hydra implements some kind of novel type of multi-asset liquidity pool called Omnipool, which will live in Polkadot. Both this project creates a synergy where you can bootstrap liquidity on Basilisk and then move it to Hydra Omnipool. So naturally, we will deal with many assets, and hence we will have to handle also many different existential deposits, and each deposit accordingly. We can dive in, and we can say some wise words, because that's why we are here. But before we talk about the existential deposits, I believe that we need to briefly mention some details about accounts, how Substrate handle accounts, how Substrate actually knows that it can kill an account. Account in blockchain, your precious tokens are usually tied to an account. In Substrate, account is identified obviously by account ID, and some additional data regarding your account are stored on a chain. In Substrate, it's the structure called account info. This is how it looks like. At the moment, we are not interested in nonce or data, so we ignore those. But we can see there are three counters: consumers, providers, and sufficients. These counters are basically deciding factors about your account on a chain. If all three of them are equal to 0, your account can be ripped, can be gone, dead, deactivated, however you want to put it. So each of these counters serves a different purpose. Consumers, it's number of modules that depend on this account, on this account existence. Providers is number of modules that allows this account to exist, and sufficient as well is number of modules which allow this account to exist, but only for their own purposes. So now the question is, what is increasing and decreasing these counters, and how it is related to existential deposit? It's in case of balances palette, it's where the existential deposit actually comes to play, and when a new account is created, palette balances increases the provider's counter, and on the other side, if the account is killed, it's decreasing this counter. So what it is, the existential deposit? We can define it as a minimum balance that account needs to have in order to exist on a chain. If you already worked with Substrate, you have probably seen events like this: new account, end of transfer, and if you're lucky, and that's the event you want to see, is the killed account event. So that means that all the references which I just mentioned have been removed, and all the counters are equal to 0, and your account is no longer needed on your chain. But in case, for example, there wouldn't be existential deposit, or you set your existential deposit to 0, like we did for quite some time in Basilisk, this would never happen, and account would be still referenced by at least one, in this case, balances palette. So there would be at least one provider, and account would not be killed, and it would take up some storage, and even when it doesn't need to. If the account balance drops below the existential deposit, the remaining amount is considered to be low enough that it can be either transferred to another account or burned, if you like. So-called this operation we call usually dusting, right? So the remaining balance is therefore called dust. Let's quickly also mention that we have actually some kind of protection to avoid losing your remaining amount, the remaining balance due to existential deposit. Transaction usually fails if after the transfer the remaining balance would result to be less than existential deposit. In that case, you will get and you will see the red even, which is on the picture. Each chain can obviously set its the existential deposit differently. So let's have a look at some examples. You probably know that Polkadot has currently set its deposit to 1 dot, Karura 0.1, Kusama, some very low number, and Basilisk has currently set its deposit to 1 BSX. Question you may be asking is, why do we actually need it? Why we cannot just keep an account as long as there is something on it, and only kill it when the balance of the account is a 0? Well, first of all, the remaining balance could be so low that it wouldn't be possible to do anything. You would not be you would not be able to execute any transaction because there wouldn't be enough to pay a transaction fee. So the reasons why existential deposit exists is so a chain can be efficient, can be safer, and eventually can be cheaper. Because the more stuff you have on your chain, the less efficient it becomes, the more expensive it will be to execute transaction. And also, for example, you can easily flood a chain and create arbitrary number of accounts with no balance. And we live in multi-asset world, and hence we will have many different assets, many different existential deposits. So that means lots of dust can be left behind. I have prepared a short demonstration, short video of a scenario where existential deposit would not exist or would be set to 0. I have a little tool which I called HydraDX, nothing fancy really. I use it to poke around and make some holes in Basilisk, but I can create some scenarios and repeat them quickly. And one of them is a scenario where I transfer some amount to a new account and immediately transfer it back to the original account, leaving the new account without any balance. So we can now watch and see what happens if existential deposit is set to 0. We can now play the first video, please. Okay. On the left side, we can see the total number of accounts in the system. And underneath that, we see number of accounts without any balance. No, that's the incorrect video. That was the second one. Okay, this is the second one with okay. So on the left side, we see the total number of accounts in the system, and under we see the total number of accounts without any balance and with one reference only. On the right side, we see the events for each block. So we see the only accounts are created and the number of accounts is increasing and increasing. So now we can play the second video where we actually set the existential deposit to some reasonable number and it's greater than 0. We can immediately see the difference. We can see the killed account, which we haven't seen in the previous example. And the event is what we want to see is the killed account. That means that as soon as we transfer everything out of the account is killed. So what this means is that the reasonably set existential deposit can prevent, for example, this scenario or any scenario where some stuff would be left behind. Okay, we can move back to my slides. How can we configure existential deposit? Where you can set your existential deposit? We will have a look only in 2 palettes, the most used palette, I believe, balances and tokens. In case of balances, you set your existential deposit by implementing a get trade where you return the amount for a native token. In case of tokens, you need to implement get by key because you also need to provide for which asset you want the deposit to be returned. And besides that, you also can configure a handler to handle accounts dust. Within this handler, we can do something with the dust. We can either transfer it to a different account, such as treasury, or we can even burn it if you like. When do the existential deposit comes to play? Simple answer, short answer, basically on any balance change. For example, during each transfer, the existential deposit is checked. And if the remaining balance would result in less than the existential deposit, the transaction would fail. If the remaining balance is 0 after the transaction, after the transfer, then the account is killed, and we will get the killed event. And as I mentioned at the very beginning, we also have a keep alive flag to prevent losing remaining balance due to the existential deposit, so we can control what you want, if you want to allow the account to exist or not. So now we can have a look how we handle existential deposits in Basilisk. In Basilisk, we have many assets. We implemented our own asset registry, and every asset has to be registered first before it can be used. In Basilisk, when registering a new asset, you also provide some parameters, and one of these parameters is existential deposit. Using a price oracle, the value of asset can change, and also the existential deposit can change based on the value of the asset, and this can happen at any point, basically. So now the question is, how can we dust accounts which balances were okay, were still about the existential deposit on the last balance change, but now after the deposit has changed, are below that value. In Basilisk, we implemented very simple palette, which we call Duster. It's a simple palette which has only one dispatchable called Dust account. Anybody basically can call this method, and when providing the account and also asset ID, the account which can be dusted, and in return the caller will earn some reward, and also transaction fee can be refunded as well if desired. How the caller figure out what accounts can be dusted is on them, but in case nobody would willing to do this, we have also off-chain duster, which we can run, and it will go out and seek and destroy all dust accounts every end block. Before we wrap it up, I also prepare an example, a short example, quick example, which demonstrates everything that we talked about in last 17 minutes. So let's have a look at this example. Let's imagine that we are at block 10, and our registry looks like this. We have only native token, and its existential deposit set to 1. And our account storage currently looks like this. There is only Alice holding some BSX tokens. So we register an asset. Let's register KSM, and we set the deposit to 5. That's written in registry. So let's fast forward to block 100. During that period, there were some transfers, and our account storage looks like this. We have some new accounts, Bob and Charlie. Alice acquired some KSM tokens as well. So as we can see, all the amounts are still above existential deposit, so nothing can be dusted at the moment. But now something happened, and the value of KSM tokens changed, and according to the new value, we also need to update the deposit of KSM. So we updated to 15. So that means that all the accounts which hold KSM can be now dusted because they are low enough. And unfortunately, let's say nobody, no Alice, Bob, or Charlie have any desire to do anything with these tokens anymore, because it's not worth it for them to transfer them out, because to pay the transaction fee to transfer them out is probably too high to accept. If we did not have any dusting strategy, it would remain like this. Yeah, they say, okay, we leave it on your chain, we don't need these tokens. So if you didn't have any strategy, it would remain like this. It would take up some storage. But actually now we can use the duster, which we talked about. So let's jump one block forward, block one, so we can write all the changes regarding the KSM deposit to the storage. And now we can call the dust account method. We can provide, we can see that we can dust Charlie's account, Bob's account, and Alice's. Oh, wow. Charlie's account has been removed completely because Charlie didn't have anything else other than KSMs. And Bob and Alice still hold some BXX, so only the storage of the non-native tokens has been cleared. Okay, so summary. What you can take from this presentation: don't forget about your existential deposits. Have existential deposits set to some reasonable amount. Choose your dusting strategy, and if you deal with multiple assets, don't forget about those and set deposits and dusting strategy for them too. So thank you very much. That would be all. If you have any questions, I will be here for a few minutes, and I will be also in the Discord channel.
Martin, thanks so much. Super interesting. I think it's kind of nice to have a talk that's so focused on, like, really one thing, right? This concept of using existential deposit, and obviously like kind of using the API capabilities around it. We have a few questions, and we have a bit of time for some questions. So I'm going to jump in with a question that just came in. I think will kind of help people sort of like situate themselves to like what we're talking about, right? We're talking about capabilities with Substrate. It's not necessarily specific to your project, Basilisk and HydraDX. So the question is dust removal a feature that's part of a Substrate palette for accounts, or is it just on Basilisk?
No. It's part of the balances palette, for example, or on tokens palette, or it can be part of any palette which actually deals with tokens. It's not a feature of Basilisk, it's a feature of Substrate.
Yeah, and there, you can find the actual source code of like in the balances palette where it's being used. So I invite you to do that, and you'll kind of get a better understanding as these are tools that you can use, and they're kind of available as within the framework of Substrate, but not necessarily unique to each project. So there's another question: is how often do you need to run your dusting or your dusting tool or your duster?
Yeah, that's what we still need to figure out. We haven't had a chance to have many accounts yet in our chain, so we'll see. After a few months, I guess we will see how often we need to run it. How often there will be accounts with less than the existential deposit.
Right. That's interesting. So you're basically kind of manually running it every other day when you see maybe that there's more activity on the network?
Yeah, we will have, like I said, the off-chain duster, which will every, I don't know how many blocks, but maybe 100, it will just check if there is anything to dust. But you can still do it off-chain, right? You can still somehow figure out what accounts can be dusted, right? So maybe obviously, you can listen to some transfer events and keep a track what accounts has some lower amount, and just understand when there is less than the existential deposit.
So a couple questions on Basilisk is, and I'm mentioning Basilisk because I mean obviously there's HydraDX and Basilisk, HydraDX being on Polkadot and Basilisk being on Kusama, but so I mean I'm mentioning Basilisk meaning both projects in terms of
Yeah.
their capabilities, right? So how does does the extensional deposit apply to an account that's holding maybe like a very expensive NFT, but not necessarily the asset that corresponds to the existential deposit capability?
Can you
So,
repeat
so,
it, please?
so if someone is holding an NFT, say
Yeah.
that is worth that bears value in the system,
Yeah.
how does the existential deposits? How is an existential deposit handled in that case, where maybe the account doesn't have the currency that the existential deposit is listening to, so to speak?
I believe if you have an NFT, you have also a deposit for that NFT. So
Yeah.
that means the dusting the amount of the account will take into account also the deposit for the NFT. So even if you
Right.
had less remaining, there would be still together with the deposit will be still probably about, not probably, but very likely and for sure about the existential deposit, because the deposit would be more than existential deposit for the NFT. I mean. So
very last question is where does the dust balances go in the multi-asset system of Basilisk, for example?
You can configure it as you want. Yeah, you can transfer, you can burn it, but you don't want to do that really. But yeah, treasury account. That's the answer.
Fantastic. Well, Martin, thank you so much. This was a really great talk. Like I said, very focused, very sort of picking something very specific, and hopefully it inspires those listening about innovating using these tools. Right? These are like primitives that you can use how you want. Like Martin was showing, Basilisk is implementing it in a certain way. Kusama has it in its own way, as does Polkadot, and we can add more logic to these things, which makes it very interesting and attractive.